Hey everybody, it's Brian. I want to show you just specifically a little demonstration of on Statpowers, the population simulator, making a linear model. So what I'm going to do is I'm going to create a simple linear model. So I'm going to actually create two variables. Okay, let's have this population be the number of customers at Target. And we're looking at the person at the checkout. We're looking at the amount of time it takes them to take care of a certain number of customers. So let's have the first variable be discrete, and this is the number of customers during, let's say, a 1-hour shift. And the second one is going to be a continuous variable, and that's the time. Let's see, the total time. Actually, I'm not going to do 1-hour shift. Let's just have the number of customers. All right. So let's have the number of customers be uniform from, let's say, 5 to 30. All right. And I'm going to set there's a dependency. The total time is going to be dependent on the number of customers. I'm going to go to the total time variable, and I'm going to choose a generalized linear model. We have only one variable that's dependent on the total number of customers. I'm going to record this in hours. I'll use 2 decimal precision. And let's see, the total time. Let's say that there's going to be, let's say there's a certain amount of time, say maybe 10 minutes to sort of get in and to sort, like, to get kind of set up, and there's some maybe downtime or something. And then we want to think, well, what's the average amount of time per customer? I'm going to put 3 V1, and this is going to give us a linear model that's very simple. Right now, I can actually sample this, and we can see what the numbers come out with. I'm going to display as a table because it looks a little bit nicer. So you can see, for 30 customers, it took 100. Let's put the total time in minutes so that it's clear. Let's sample again. Okay. 19 customers took 67 minutes. 8 customers took 34 minutes, but there's absolutely no randomness involved. And you get that by adding a random term to your linear model. And you can put it in a couple of ways. I'm actually moving towards the notation of using z as a standard normal random variable, where in the model we have the epsilon. Well, we're going to use z, and you put the coefficient on z. That's going to give you the variation. Let's say I'm going to put 2z. That means there's going to be a standard deviation of 2. Actually, let's change this to be a little bit more. Let's do 10z. Okay, a lot of variation around this, and I'm going to put the lower bound to be at 0 because or let's say lower bound yet 0. I don't want this for any reason to be lower than 0 minutes, but there's no bound on the upper. So let's just see what this would look like. You can see now I'm getting a lot of decimals because of that random standard normal variable, that z. That's adding a little bit of randomness, and I've added these colors because it makes it a little bit clearer as what the different components of the linear model are. You've got your intercept, your slope, and the slope coefficient, and your variable v1, and you've got your random variation. Yeah, so this is a very simple linear model, a continuous variable that's dependent on one discrete variable. It could be dependent on a continuous variable as well. That's not going to change things. When it's dependent on the other thing that we can add, because this is a discrete variable, I can add something else. And I can say, let's just suppose that that if there were, let's say if there was 30. If there were 30 customers, then it takes an extra, I'm going to make something ridiculous, but let's say an extra 500 minutes if there's 30 customers because they have to throw a party or something. I'm making it up, but you can actually have case dependency. So I'm going to say plus 500 v1 equals 30, and that is going to give us, if any of these times we have 30 customers, it's going to be 500 additional minutes. And let's see how that works out. I'm going to sample. I don't have any. Oh, look at that. 30 customers. You see that? 605 minutes. So you can see for discrete variables, you can add these like case additional like. So that's nice. And that's mostly what you're going to be doing when you have a categorical variable. You can add those these like indicator, what we call indicator functions, to your linear model. So you can get, but that's silly. I'm not gonna use that. I'm gonna take that out. Anyway, there is a simple linear model. Of course, after sampling this, we could put this into do a linear regression and see if we can recover that intercept slope and that standard error. And of course, depending on the sample size you pick, you'll do a better job of estimating those. But that's the job for the person who's, doing the inference. I'm just building the population right now. Alrighty, it's been nice talking to you. Bye.